Good evening, everyone, and welcome to Northshire Bookstore. My name is David Wood. I'm the events manager at our Manchester, Vermont location. Now, before I introduce our presenters this evening, just a couple of quick notes. As this is a Zoom webinar, please at any point this evening type your questions into the Q&A function at the bottom of your Zoom window. Or if you have any difficulty with that, you can type it into the chat box as well. I'll save these up and pose them for you during the Q&A towards the end of the event. And finally, a note of thanks. Independent bookselling isn't the easiest job in the best of times, and the last couple of years haven't been that. And so we are very grateful, and we owe our continued existence to your support. So thank you very much. Tonight, I'm delighted to be able to introduce Riley Black to you this evening for her latest book, The Last Days of the Dinosaurs, an asteroid, Extinction, in the Beginning of Our World. She'll appear in conversation with fellow paleontologist Jess Miller-Camp. Heralded is one of our premier gifted young science writers. Riley Black is the critically acclaimed author of Skeleton Keys, My Beloved Brontosaurus, Written in Stone, and When Dinosaurs Ruled. A widely recognized expert on paleontology, she's appeared on programs such as Science Friday, Huffington Post Live, and All Things Considered, and written for Wired, National Geographic, Scientific American, Slate, and elsewhere. She's been called one of Twitter's 8 coolest geeks and was the resident paleontologist for the film Jurassic World. Her new book, The Last of the Dinosaurs, an Asteroid, Extinction, at the Beginning of Our World, published today, has been called a real-life natural history, putting the bi-link there, page-turning drama or deeply compelling narrative. One of Newsweek's 22 books for 2022, one of the Philadelphia Inquirer's best books of the month, and that it will make readers feel like a kid discovering dinosaurs for the first time. Acclaimed paleontologist and writer Steve Brusati says that The Last Days of the Dinosaurs reads like a fantasy novel backed up by hard facts and the latest discoveries, and that Black is pioneering a new genre, narrative, prehistorical nonfiction. We're lucky to be joined today by Professor Jess Miller-Camp. They are a museum scientist, a vertebrate paleontologist, and the paleontology collections manager at Indiana University Bloomington. Please join me in welcoming to Northshire, Jess Miller-Camp and Riley Black.
Oh, it's good to see you, Jess. I feel like last time I saw you was in the field, like
Yeah,
ages ago. Yeah.
several years deep into the before times.
Yes. Well, speaking of, yeah, I guess I didn't intend to write a book about a global disaster during a time of global disaster, and yet here we are.
Yep.
Yeah. So I guess, like in a sense, like I know you're kind of my host. We're gonna do some back and forth, but I'm curious, like, for you, like when you were getting into paleontology or when you were younger, what did the KPG Extinction like look like? What did the visuals look like? Because I know I had a lot of very strong images of sort of like this impact winter with these emaciated dinosaurs wandering around.
Yeah, so it was all of the like the campy stuff that you see on docudramas and everything like that, because I got most of my early education from reading every single paleontology book I could get my hands on from the kids section of the library. And whenever the KPG Extinction came up, they always tended to focus on like the days leading up to it, and then the disaster that was happening. And there was always a dead dinosaur skeleton getting picked over by tiny mammals and things like that.
Yeah, all that traditional stuff. There was, I think it came out in 1980. There was a documentary called Dinosaur that had Christopher Reeve, who was, I feel like, my generation Superman, hosting it. And I remember they had this model of a Triceratops, and they had this very, very cross-eyed, recently washed and brushed Virginia opossum, just like crawling up like out of the ground and kind of wandering around to visualize like the beginning of the age of mammals. And it's like very much what it looked like basically like imbibing all this paleo stuff for the first time. I feel like the impact winter part of it was always just like that was the part that like the dinosaurs didn't make it through.
Yeah, it seems like paleo artists really love to use the like the higher up on top of a dead dinosaur thing to show like, oh yeah, that now they've conquered them and they're going to go off and do their own thing.
Yeah, I like that you mentioned that sort of trying to find the right word for it, with the visual of it. Like it's a sense of like conquering and like domination in a sense, like that like runs through so much of sort of the background of paleo art and things like that we had an age of dinosaurs and then we got an age of mammals, and one is kind of coming out above the other, even though, like, as we well know, mammals and dinosaurs evolved about the same time and they coexisted for over 100 million years, and it's much more complicated than that.
Yep.
Yeah. and that's something that really struck me in writing this book, that like I went into it feeling like, okay, we know enough now to sort of give all these vignettes of what happened, and the moment of impact, then the following day, the following year, etc. But just like the speed and violence of what happened, especially that first day, really just, I even as I was writing it, I was almost like, how am I going to handle this? Because we have no context, I feel like, for this pivotal event in the book. So you have this roughly 7-mile wide chunk of space rock that strikes the planet, right? And all this debris gets thrown up into the atmosphere, and it starts to come back down. As it does so, it's creating all this friction that creates an infrared pulse, and it raises the air temperature to 500 degrees Fahrenheit, which is basically like an oven on broil, more or less. And there's just, there's no pre-adaptation for that, unless you're like burrow or you're underground or something like that. So like, I feel like I've been disappointing people in a way as I've started to talk about the book, where like they want the dinosaurs to stick around for like a while after and kind of taper off. It's like, no, most were probably gone in about 24 hours, and it's still just shocking to me.
Yeah.
Sorry.
Excuse me.
Yeah. So I know it, like in some of our discussion ahead of time, I sent over like a few papers that were like really influential in writing the book, like survival in the first hours of like the Cenozoic and things like that. Like as you were like looking back at like what we've learned sort of since, was there anything in particular that like really struck you about the extinction, or kind of like what our sort of current conception of it is?
Yeah. So when I was in grad school, like a decade ago, the prevailing, like there was contention about the actual cause of the extinction. There was a camp that was like, it was the asteroid, and that was the reason, with a capital T. And then there's the camp that was like, well, it was one of the reasons. There was also the massive marine regression and the Deccan traps and just all of these things at once. And it was very much leaning in the direction of, I think, all of the things when I was in grad school, because like you looked at the distribution of biodiversity in specific groups before and after, and just looking at it, given our understanding then, just looking at it from the perspective of impact, it didn't really make sense. But then, like that paper that came out that made everybody really go like, huh, it's like pretty recently, I think summed it up really well, that the impact could do it, and there was just all of these other mitigating factors that we weren't taking into account, like freshwater places being a little bit of a refugia, like the marine regression. You're going to kill off a lot of the stuff that needs shallow ocean waters, but then at the same time, you're making a bunch of more freshwater habitat as the rivers get longer and longer, and that could explain why freshwater stuff wasn't impacted as much. Whereas the paper back in the day that we were using in grad school was thinking more of the long lines of, okay, you get stuff tossed up in the air and it's toxic. It goes down in rain and that's going to build up in the water. But if there's more fresh water, then maybe there's more surface area to filter that stuff.
Yeah. Yeah. And I'm glad that you brought up that point, right? That like, this is not just an extinction that's about the non-avian dinosaurs. Obviously, like they're the stars, and then they're the animals that like, I know I miss the fact that I can't look outside and see one wandering by, even though their existence would probably mean that I wouldn't exist. But like, we're talking about like 75% of known species, really. I just saw a little comment pop up about toothed birds, that we had, like birds, the earliest birds that we know of evolved in the Jurassic, and they thrived in the Cretaceous, and you had beaked birds and tooth birds, and the tooth birds didn't make it. And we have some hypotheses about why that might be, but all these different forms of life. So like, the focal point is on the dinosaurs, and I obviously like play with that a little bit, or maybe more than a little bit. But that this really is like this global event that affects so many different forms of life, and it's striking to me, like looking back, I allude to this a little bit in the intro, but how for so long there was, I guess what Michael Benton, another paleontologist, calls the dilettante phase of extinction hypotheses, where it's like everybody who had like a discipline in whatever science or expertise tried to pull something from it. So like entomologists were saying, well, caterpillars show up in the Cretaceous and they probably ate all the vegetation, and then dinosaurs had nothing to eat. Well, that's great, but that doesn't explain like why ammonites, these coil-shelled squid things in the oceans, went
Right. And
extinct.
there's like that one ophthalmologist that was like, the dinosaurs
Yes.
all got cataracts. Like,
Yes. Yeah, and so like everybody, like the dinosaurs are such the focus, and really it's like they're one part of this broader basically pattern, and it's trying to figure out how it all goes together.
mm-hmm.
And like you said, some of the research is like it's so much like counterintuitive, not that these other sort of aspects, like this ancient seaway that you mentioned, this marine regression that happened off North America, not that wasn't important. I'm sure there were species that existed that, you know, if there's no more ocean, you don't have somewhere to live.
Right.
But beyond that, yeah, go ahead.
Oh, I was going to pop in. I think
Yeah.
regression is probably one of the terms that people are getting
Yeah.
confused about. So sea level changes that happen over like a global scale, there's regressions and there's transgressions. And regressions is when the sea level drops, so you lose a lot of the shallow areas. Like the Mediterranean Sea is a shallow sea, so a big marine regression now would mean we'd lose a lot of the Mediterranean Sea. A bunch of that would become land. Transgression is the opposite, and that means sea levels rise. During the late Cretaceous, there was a big inland seaway going up through the middle of North America. And then there was a big marine regression, so it disappeared. So that entire space that was full of like mosasaurs and ammonites and things swimming around, they no longer had that habitat.
Right. And that's certainly part of it. And so you have like that going on. And how do we like sort of parse out, you know, what's causing what? And some of the things that we thought would cause the extinction actually kind of worked against it. Like I was really blown away by a paper that came out in PNAS, you know, about a year or so ago. You know, thankfully, when I was writing the book, we were talking about the Deccan Traps, right? This major volcanic outpouring, not like spewing into the air, but like basically like the earth like separating, like oozing in what's now, or at least prehistoric India towards the end of the Cretaceous. And the timing never lined up quite right. It kind of starts before the extinction, it goes on after the extinction. And it used to be this major contender because we know in the past that major volcanic eruptions have caused mass extinctions.
Mm-hmm.
And yet in this case, it seems like there was enough sort of greenhouse gases poured into the air from that volcanic activity to warm the atmosphere during the impact winter a few degrees higher than it otherwise would have been. So the extinction actually might have been worse if we didn't have all this volcanic activity.
Which is just
that,
wild.
Yeah.
Especially when you think about Krakatoa causing a tiny winter. It's just like, how did like I'm not an atmospheric scientist, so the fact that these two things could combine and end up like switching the signal around is just wild to me.
Yeah, I feel like so much of it, like you were saying, like even in the past 10 years, sort of our view of this has certainly changed quite a bit. And that's why I wanted to write this book, in a sense, to kind of dig into some of this stuff, because I know I'm guilty of it in some of my past writings, where it's like, okay, well, of course, if a 7-mile wide chunk of rock hits the planet, it's going to cause some kind of extinction. It's going to be bad news. And yet, when I thought about it further, it's like, well, wait, we have craters that are as big, if not bigger, that are not tied to mass extinction. So what was it about this particular one that just kind of was the worst case scenario in so many different ways?
Yeah. I remember in grad school, they had a speaker come at one point who was a sedimentologist of some variety. And he was talking about the Chicxulub and saying that one of the reasons that it was so devastating is because it hit a carbonate platform.
Mhm.
Carbonate platform means just like a big area that's pretty deep of like limestone and stuff like that. So I don't remember what exactly the reason was, but it was something about all of the carbonate getting kicked up in the air made it more devastating than like the later bigger impact that happened in Siberia that didn't really do much of anything.
Yeah, and that's exactly as I understand it as well, that you had this basically remnants of an ancient reef ecosystem. So something that was already once alive, it's fossilized, it's become this kind of limestone now. And by the time the asteroid struck it, it's full of all these sulfur compounds. Basically, all these
Mhm.
sulfur compounds get thrown into the air. And we know from just observations, like in our modern world, that you throw a lot of aerosolized sulfur compounds into the air, they're really good at reflecting sunlight. So you have some compounds that are thrown into the air that are good at like creating global warming. There are some that contribute to global cooling because they're reflecting sunlight back. So it's like, I feel like it was so complicated trying to tell the story because there are all these different intertwining sort of factors, and like one thing's doing this, but something else is doing that. And this comes into play in the first day, but then you have years of impact winter, and that this extinction like played out in a sense that there wasn't just like one cause
Yeah.
for everything. That, you know, the first 24 hours in that infrared pulse probably took out quite a lot, and quite a lot of the dinosaurs that, you know, couldn't get underground or hide, lots of other organisms. But even for the survivors, it's kind of like, okay, you made it through like that first barrier or boundary, and now there's going to be years of almost the complete opposite, where photosynthesis almost halts. There was a
Right.
paper in particular. I include a little bit about this, like in a coda to one of the chapters. These little things called coccoliths, and they make these called coccolithospheres. If you imagine like a microscopic frisbee, but it's algae, that's pretty much what they are. And you see the signal where like through the extinction, before it, you have kinds that can like eat organic matter as well as photosynthesize. So they can both like consume organic matter and make their own food. And then afterwards, like all the photosynthetic ones are gone. And they're just what they call these mixotrophs, these ones that can like feed on not so much other organisms, but on organic matter.
Mhm.
And that was kind of the saving grace of the ocean. So the ocean's almost entirely collapsed because they're based on phytoplankton, or plankton that can photosynthesize. So if you take that ability away, you know, I think the authors of that paper in particular told me that like this was as close as we got since like the origin of animal life, of the ocean returning to like a single cell state, more or less. Like it came like without these things that just happened to be able to like subsist without photosynthesis. Like it would
Right.
have been so much worse than it was.
Yeah, it's a good thing they exist.
Yeah. Well, and that's the weird thing, is like it was devastating and it was awful in so many ways. And yet so many critters made it through. Like it
Mhm.
still blows my mind that the first primates that we know about are from the end of the Cretaceous, that you have these little things called Purgatorius, these little things that look like tree shrews that, you know, lived at the same time as T-Rex and Triceratops. And they're, so far as they're categorized, the earliest primates. So like our own family was there, it existed for this event. So it didn't just come after, but like primates made it through and then thrived on the other side, where we could have just as easily been like snuffed out with the dinosaurs. So it kind of like affected my thought process so much, thinking like, because it's often framed in terms of, right, like the non-avian dinosaurs disappear, mammals are allowed to flourish, the earliest primates are among them. It's like, no, we were like a hair's breadth away from like vanishing in the same extinction.
Yeah, so it makes you wonder like how much of the primary, like the lowest level of the food chain switched from plants to fungi on land,
Yeah,
because there's going to be plenty of stuff around rotting that they can eat, but not so much for photosynthesis.
yeah. And that kind of gets back to that comment earlier about the enantiornithines, the toothed birds. Because there's a paper that came out of a group based in Canada saying like, okay, prior to the extinction, right, we have toothed birds, we have very like bird-like raptor dinosaurs basically, and beak birds, and only the beak birds make it through. So what does that tell us? What does that mean? And their hypothesis is that the beak birds like basically had already switched to like a form of like herbivory where it's focused on like digging up seeds and nuts and like basically grinding them down in gizzards. Like all those components had already evolved.
Hmm.
But if you were feeding on insects or little lizards or things like that, that basically there would have been like so little to eat. If you're a carnivore, you basically would have still starved because the ecosystem is entirely collapsed. Like you're up here and all these levels in between you and the primary producers are gone. So it like was these birds that were able to subsist on like the underground storage organs, basically like the seed bank, that
Hmm.
were able to make it through. And like you said, like to think of these landscapes that were just like possibly cleared out by heat and fire and then suppressed by a lack of ability to photosynthesize. So like those must have been incredibly strange ecosystems in those years that immediately followed.
Yeah. And I don't think anybody's looked into it, but you have to wonder, like, you look at things like horses and and cows chew their stuff a lot, like multiple times. So they're really
Yeah.
efficient at getting energy from food, whereas something like a horse isn't going to chew it as, or isn't going to digest it as much. So they
Yeah.
need to eat a lot more to get the same nutrient and same energy back from it. And it makes you wonder, like, were there any groups where like one group that survived had more efficient digestive system versus something that died?
Yeah, I'm kicking myself for not thinking of this earlier, because now that I'm thinking about, it's like, well, wait, if we have all these, critters who are basically birds in particular that are eating, seeds and nuts and things like that in the seed bank, there are some seeds that seem to benefit from like going through the digestive system of an animal.
Hmm.
This coevolution probably already exists. So like, did those surviving birds in a sense like help replant in the years following, like once those sort of aerosolized sulfur clouds and stuff started to dissipate, or the impact winter ended, like did they help ecosystems recover more quickly than if
Yeah.
though that relationship hadn't existed? Because we see that with insects in a sense, where like there was a mass extinction of insects. I think there's a particular study of fossil plant leaves and looking at all the like insect damage on it. So you're not finding the insects
Hmm.
themselves, but you're finding what they do. And most of those forms of insect damage like disappear across the boundary, but then they come back. So it was like this re-evolution into familiar niches, familiar like modes of existence, so that even though you have this basically break between them, whatever made it through kind of set those conditions for what followed.
Yeah, and the insect thing is particularly applicable to today, since we've got like, what is it, like 70% of insect populations have dropped since,
Mm.
what is it, 70s that they measured from, with that big paper that came out like a decade ago?
Yeah, I forget the exact figures, but it's sounding very, very familiar. That yeah, we like I know entomologists and like no, we really are in trouble when it comes to insects right now.
Yeah. Because like you go on cross country road trips and you don't have to stop every hour or so to clean the bugs off your windshield anymore. And I remember having to do that fairly often when we were a kid. But yeah,
Yeah,
so it's like, what what were things, because the insects are right above the primary producers in the food chain. Like, what were things eating when an entire level was just not there?
yeah. Yeah, I mean, and those are the sorts of things where it's like I wish I had more hard answers for. I could certainly like cite the literature and write about it, but it was sort
Hmm.
of like filling in a little bit like, okay, how would this work? And this is kind of my best guess for that. But like that's why I wrote this big appendix, try and be like, okay, I'm basing my take on this. I might be entirely wrong, or someone's gonna come out with the paper next week, next year, whenever. That kind of revises that. But that's science, right? It's like
Yep.
that's kind of the terror of publishing anything scientifically minded, is that as soon as it's out there, possibly even before, that
Yep.
there's gonna be something else that comes up and alters what you expected.
Yeah, I remember there was one year at SVP where these two people were studying something very, very similar, but one of them had information that the other one didn't. And unfortunately, that guy went before the other person. And the second person had to get up and be like, well, everything I'm about to say is wrong because I didn't know that. And that changes everything. It's like, oh, that really
Oh,
sucks.
yeah, but I mean, that's great grace on the part of that person who did that to be like, oh, okay, well, I'm running with this, but yeah, need to make some adjustments. But I
Yeah.
wanted to ask, like, given like your handle on social is Dead Gators, and you obviously know quite a bit about our crocodilian friends. What do you think about like how or why they might have made it through the
I think
KPG
being
extinction?
a lot of them being in freshwater habitats had a lot to do with it.
Yeah,
Um, they're also, since they're cold-blooded, unlike what we assume the dinosaurs that were around at the end of the Cretaceous were, um, they can go without eating for longer. And as far as like nuclear winters go, the alligators in particular can it's not quite hibernation, but it's called brumation in reptiles, but it's kind of
yeah,
this a similar kind of thing. They can do that a little bit and slow their metabolisms down for a little bit. Um, but you do still see a shift in what you have before and after. I think it was something like half of the species that we knew in the late Cretaceous died, or half of the lineages at least. And all of the big ones were gone. So anything that was
Yeah.
like 20 foot, 15 foot was gone. But you did still have things like Brachycamps. There's an alligator that was like 10 feet long, and you still had it making it through. But for alligators in particular, so alligator reens specifically, which is everything that's closer to the American alligator than to caimans, they were small for a while. Like a couple of the early ones may have been like 10 feet, but then they got down to like 5, 6, 4 feet. But then you still had them alongside these crocodiloids, which not necessarily not in the same crown group of crocodiles today, but something related to them just further down the family tree. Um, they were still fairly big, so it seems like they recovered faster for the size. But you did see a shrinking of the size for crocodilians for a while.
Yeah. Yeah, like I said, like even amongst the groups that we think of as like survivors, that there were still losses and there were still extinctions. And I included sort of a caiman relative based upon some of the fossils of coming out of the Coral Bluffs area in Colorado. So like this 100,000 years to 1,000,000 years after impact sort of time period, saying that like a lot of these sort of crocodilians look relatively ancient, right? But like I know some of the recent research suggests that like they're evolving quickly into like the same forms,
Yep.
more or less, so that we're kind of like replaying, like filling the same niches or feeding styles or things like that. So like even when you look at like an alligator or croc today, you're looking at something that looks like incredibly ancient. You can say like, oh wow, like what was it like when that was around the Jurassic? What's like, well, the Jurassic equivalent of that belonged to an entirely different group, and they're kind of repeating this niche over and over again. And just like you said, once you get into the details, like beyond just sort of that 1,000-foot view, but really down to like, okay, who made it through and then what are they doing? The kind of new things, but also reinvention of things that existed before.
I think another thing that helped crocodilians get through is this thing called niche partitioning. And that's where you have throughout an individual animal's lifetime, they're not eating the same thing the whole time. So something that's slow growing, like a crocodilian, when you're a baby, you're going to be eating like, little insects, little crawdads, things like that. And then you get a little bit bigger, maybe you start eating small fish, maybe little lizards and things like that. But then you get a little bit bigger, maybe you start adding small mammals. So the juveniles are not competing with the large adults. The babies are not competing with the teenagers. So that lets more individuals in a population exist at the same time, which makes your genetic pool a little bit stronger and makes that species more likely to survive. Versus if you're looking at something where they don't have really big niche partitioning throughout their lifetime, you're going to have babies competing with adults. And if you're in a famine situation, you're not going to be able to support as big of a population. So you're going to be more likely to, if something else happens, everything just collapses.
Yeah. And I liked your point about cold-bloodedness as well, because we often, I feel, in depictions of paleontology, especially like of the Mesozoic, that we kind of elevate critters that are either, by whatever physiological means, are warm-blooded or incredibly active, or they grow quickly. Like there's a sense of superiority, I guess, in a sense that like, non-avian dinosaurs or, crocs that evolved to be similar or what have you, that they were kind of like took a step above and they became like more mammal-like or more bird-like. But during this extinction, it seemed like that would be such a disadvantage to have like a hot running metabolism that you have to feed constantly, and being ectothermic, being able to, like you said, undergo these forms of brumation or equivalents of hibernation or stretch your meals out longer. That was kind of like these things that we might think of, okay, when you're looking at like the peak Hell Creek Formation landscape and you have T-Rex running around and stuff, all these ectotherms in the background seem like kind of bit players, when really like under stress, that's part of what helped them get through.
Yeah, I'm sure anyone in the audience who's raised a teenage boy can relate to how much your wallet gets hit by all the food that they suddenly need because they're growing. So it's the same kind of thing there. The metabolism gets ramped up and you need more food.
Yeah. And when there's not very much around, then you're kind of stuck. I wanted to ask, since we're kind of getting around like the halfway point, and I know we're going to do questions soonish. For you, like when you think about the KPG extinction, so like the world before and the world after, like what are some of the questions or like outstanding like puzzles to your mind that we have? Because obviously like the book that I wrote, it's like based upon what we know now, but it's far from the final word on this subject. So I'm wondering, like for you, what things would you love to know if you could have a paper come out tomorrow that kind of gives a piece of information? What would you like
I
to
want to
see?
know why amphibians weren't really affected,
Mm,
because they're so sensitive to environmental change, and they're just like, whatever, new day, and just
yeah.
it's just so confusing. Um, yeah.
Yeah, that you would kind of expect them to take this hit. And I remember
Hmm.
ages ago saying like, I talk about it a little bit in the book, but the emphasis on, acid rain and how that would have should have affected amphibian populations. Even now, we're not entirely sure. It seems what the relationship is there. Sometimes it does and sometimes it doesn't. But yeah, you're right that like out of all the groups that there are, like frogs and salamanders and stuff seem to be like just fine, that they're
Hmm.
okay. It's like, how is this possible?
Yeah.
I think for me, there was a paper that by some of the people in the same group as that Deck and Traps paper I was mentioning that pointed out how we have these studies of dinosaur diversity, right? That so we look at often like time, what we call time bins, so slots of time that 75 million years ago, so like 10 million years-ish before impact, we have a lot more dinosaur species in Western North America, like up and down. The continent. By the end of the Cretaceous, it seems like a much more homogeneous
Hmm.
community. But when you correct that for like the amount of exposure there is,
Yes.
you start to wonder like, well, hold on, we're not like comparing apples to apples here. Like that there's, because of that marine regression that you're mentioning, because we have the seaway that created all this wet lowland habitat and that's gone. Are there species that existed even on our own continent that we just have not found yet,
Yeah.
or at least or that we can't find? So in trying to estimate like how well were the non-avian dinosaurs doing and stuff, it's difficult to do that because we don't even have like the fossil record, as we well know, is incredibly sometimes frustratingly incomplete. So and that's even just our own continent. So it makes me wonder about like what's going on the other side of the world. Because this was
Hmm.
a global event, and so much of what we know comes from the Hell Creek Formation, the overlying Paleocene formations in the Western U.S. So what was going on in like South America? What was going on in Cretaceous Africa? What was going on really almost anywhere else? Was this playing out more or less the same, or were there some places where it was staggered? Or there are all these like pieces that, we have this really epic story with these incredibly charismatic dinosaurs that we love so much. But it makes me wonder if somebody can find this good, Cretaceous to Paleocene section somewhere else in the world. What is that going to look like? I'd love to see that from like I said, from the global south somewhere and see how that compares.
Hmm. And then there's like, it seems like most of the what little rocks we have from the earliest Paleocene and latest Cretaceous, they seem to be concentrated in the mid latitudes in both the north and the southern hemisphere. Like, what is going on in the tropics and the subtropics? Because there's got to be something it's got to be affected differently because of all of the high level atmospheric currents that are going on, and because there's going to be more change away from the equator than close to the equator, typically when there's a big environmental shift. So it's like, was there refugia down there in the tropics that things fed out of, or was it worse off because that's where the Chicxulub impact was? And yeah.
Yeah, there's so many components to this. Like it's such a the book that I wrote, it's like, okay, this is like the best window that we have, but it's kind of like looking through just one of them. It's just trying getting this picture of like an entire landscape just through one frame. And I'd love to know more about this. We can certainly look before and also, yes, I'm glad that people noticed that it's almost dinner time, so he's sulking a little bit. But yeah, I really wonder like what the next years are going to bring, because there's so much research about this. I feel like almost every week there's something else. And I know in particular like a lot of people are excited about the site that's been nicknamed Tanis in the Dakotas, and like whether it may or may not be from within hours of the impact itself. There are some, I think, certainly some technical and some scientific issues with what's being brought out from that site and how it's being presented. But what I'd love to find, like the site itself is super cool, aside from some of my misgivings about the way that it's being marketed to the public.
Yeah.
I'd love to see another one, either from, even if not from North America, from somewhere else in the world, if there's another spot like this that we can kind of narrow down the time frame. Because like the more, it's like connecting dots, right? If you just have one dot, it's like, hey, well, that's a dot. And it's kind of this size and this shape and this color. And then you have another one, so like, okay, well, how do those two compare? And then you can start connecting all these things. And I wonder by the time that, I'm a fossil myself, what the picture of this is going to look like.
Yeah.
For sure. Well, I see that we have a bunch of questions popping up, so I'd love to get to some of those so we can make sure we get to everything on time.
Hey, it's my pleasure. This has been a great delight. We've got several questions from Desmond, who I think is a kid who had to leave earlier. But let's start off with one of his. Which is your, and I'll expand on it a little bit. Yeah. What is your favorite place to find dinosaurs? And could you expand on that and talk a little bit about, field work and what is that like for us, non-paleontologists?
Yeah. So for my part, I do a lot of field work. I've been doing it for about 11 years. A lot of it's in the Mesozoic, so what we think of as the age of dinosaurs, that 3-part Triassic, Jurassic, Cretaceous time period. But I also do a lot sort of the time period before and the time periods after. I've actually been out in the field with Jess at doing Ice Age field work in places like Wyoming. And each place has its own flavor. It has its own sort of approach to it. There are places where I've done field work in caves or just walking out in the landscape or basically in like a mucky kind of pit. So you're always wondering, like, what's the landscape? What does the rock look like? What am I looking to find? What color is it? What's been found there before? So it's incredibly variable. But in terms of my favorite places to go, I'll answer this in 2 parts. My favorite place to go find dinosaurs is probably the Morrison Formation. So that's this late Jurassic rock unit, dates to about 150 million years ago. This is where we get Allosaurus, Stegosaurus, Apatosaurus, like all those classic dinosaurs. And we have a lot of exposures in Utah. And it's just beautiful, beautiful rocks. It's gorgeous. And I really like working out there, particularly a place called Cleveland Dinosaur Quarry, which is a big bone bed that contains the remains of at least 48 individual Allosaurus that have all been strewn together. But my favorite place for fossils, period, is the Uinta Basin, which is on the Utah-Colorado border. It dates to about 43 million years ago, so this is well after the impact that we've been talking about from this conversation. And it's when mammals are really starting to undergo their big evolutionary radiation. You're getting a larger range of body size and niches and sort of adaptations and body shapes and all that sort of thing. And it's stunning out there. The rocks are these beautiful purple and maroon and gray colors. You can easily walk. You can just kind of pick a direction and walk and go look for fossils. And if there's a problem, it's that there's so many turtles. There are more turtles than you'll ever have time for. And you go 10 feet, it's like, oh, more fossils, it's a turtle. And you walk in, and like, no disrespect to turtles, are very important. They can be great environmental indicators, but we're usually out there looking for mammals and stuff. And I love that particular field site. And that's the fun part of it, is you really never know what you're gonna find. Jess, what would you like to say about field work?
I haven't done much field work. Most of my work has been in museums, looking at things that have already been prepped and then compiling data from all of them to answer like big questions about the group. But other than avian dinosaurs, the only place I've been to that I found a dinosaur was a cow pasture in, I want to say it was Utah. There was a trip where when I was an undergrad, we did a trip out west. We were in North Carolina and drove all the way out to Utah to Jensen. And on the way there, we stopped at a place where a rancher had this big hill that he wanted to mow down and turn into a new cow pasture. But there were bones there. So he contacted the local museum and was like, hey, come get the stuff. I don't want to just destroy it. So we went out there and they didn't get the permits in time to actually let us dig. But walking around, I ended up like hopping off a side, and underneath this overhang was just this Allosaurus femur. And that was like the first dinosaur fossil I ever found. I was like, ha ha. And nobody else found anything that good that day. So it was just like,
That's the thing. It's like I feel like I'm not normally a very competitive person, but fieldwork can kind of bring that out a little bit. Like if somebody finds something, you want to find like a better thing. And yeah, it's funny how that goes sometimes.
Those are great. I've got a question for you both. So Jess, you were saying earlier about what you had heard in grad school, and I remember from a kid wanting to be a paleontologist, there was still some question about what was the cause of them all, and how did it get sort of narrowed down to the asteroid as it was always sort of understood to be when I was a kid, and particularly how was it decided that it was Chicxulub?
it was decided that before I was in grad school, or at least that was one of the reasons. And there was just all these competing lines of evidence, like we were talking about, like the biodiversity. So, like, how many species in a particular group are there across time? How similar are they to each other? But then there was also the geochemists with their information and the atmospheric scientists with their climate models. And there was a period where they weren't all lining up with each other with the data that we had. So I think just over time, learning more and refining the models and things like that made things able to start honing in on one answer.
Yeah, in terms of, to just jump in on the impact crater side, it was discovered, from what I understand, about the 1960s. It was actually like oil geologists who were basically looking for new places to mine in the Gulf of Mexico, and they came across what seemed this really just disturbed rock. Because when you think about what the impact and what it did, the asteroid strike, and it basically pulverizes and melts a ton of rock, and it sends all these huge tsunamis out basically, and around it, and they were so strong that those tsunamis hit the coastline and rebounded backwards. So it didn't even just like stop on the coast. They came back and they brought a ton of sediment with it. So they basically found this sedimentary layer that it was just chaos, for meters and meters through it. It's okay, this is something interesting, but we didn't understand what that meant. It seemed like it's some kind of impact structure. It wasn't until 1980 that we had the impact hypothesis codified, based upon basically what we now recognize as the KPG boundary, like the boundary layer between at the end of the Cretaceous that has evidence of some kind of impact. And then there was debate about that for a very long time. And it wasn't until about 1993 that those two things got brought together and saying, because people started to look, so do we have any candidate craters on the planet? And it took over a decade before it was really narrowed down to Chicxulub. And since then there have been a few other propositions, but that's the one that's like the timing is correct, the location is correct, like all the details that we're finding out about it. And as Jess was saying, a lot of these other models, they used to be sort of in conflict, but they've come closer together as we've done more refinements on like when certain events happened in relation to each other, what the consequences of those things would have been. So really, I mean, this is science, right? It's like, it's not like somebody makes one discovery and everybody says, aha, like, and I never knew it. It's like, there's so much argument and debate and checking over again. And that's one of the reasons why I think this story is really compelling now, is because all these things are starting to thread together and give us this image that we never really had before.
Thanks. There's a great question here from Mars for both of you. They ask, where did you go to school, and what was your college education like, and do you have any recommendations for paleontology students?
Yeah, I'll jump on that first because I think mine's pretty easy. I actually dropped out of college 2 credits short. I went to Rutgers University to study ecology, which they have a great program there. I wasn't doing super great in it, but I used my university access to start reading books and papers about science and paleontology and writing about them. That's what led me to this career. That route may or may not be open still. It was kind of like during the rise of like science blogs and things where like we were talking to each other online a lot more before things got fragmented. But in terms of schooling and stuff, I think as far as I know, the only undergraduate paleontology program in the country is at the South Dakota School of Mines. That's where you could get like a BS in paleontology. Otherwise, you typically have to get a biology or geology degree. And then as a master's student, you can become more specialized in paleo. So that would be Yeah, unless you plan on going to South Dakota School of Mines, chances are that you want to pick, okay, am I more interested kind of in the geological context and figure out like how fossils form and how they're laid out, or like the biology of the animals, and from that direction, that kind of opens up different pathways.
So I went to Appalachian State University in North Carolina for my undergrad, and I got a geology major with a biology minor there. Nowadays, they're offering a paleontology focus with a geology major. Um, I actually fulfilled all the stuff for that, but because of timing, it didn't become possible for anybody to actually be rewarded that until the semester after I left. Um, then I did my master's at the University of Iowa, and then I stayed and did my PhD at the University of Iowa. And Iowa, there's a crater there that was actually one of the candidates for um, the KPG crater, but I think it was ruled out well before 1993. Far as recommendations for paleo students, as an undergrad, be a generalist, like sample everything you can. You're just getting your first taste of the field, like interacting with professionals at that level. So there's so many different ways that you can do paleontology, so many questions you can look for, so many methods, and so many types of jobs you can end up going into. So use that to like sample, like treat it like a sample platter. And then for grad school, you want to start thinking more about like, okay, I don't want to do research, but I do want to be involved in paleontology. So what can I do with that? Like maybe I can be a collections manager, or I really want to do research, but I specifically want to work with models, not with the fossils themselves. Who can I go to work with that? When you go to grad school, you want to look for an advisor who they don't necessarily have to work on exactly what you want to work on, because you're going to have a committee that can be comprised of people outside the school you go to, as a PhD student at least. And you can pull other people in to answer questions like that, but they need to have the qualifications to be able to guide you in whatever you want to do. Um, you want to talk to their current grad students to make sure that they're actually a good fit for you. You don't want somebody that's not actually a good advisor, and somebody can be a good advisor but not be good for you, because everybody's got a different advising style. And you also want to ask them about the department itself, because you can have a great advisor, but if the department is toxic, you're going to have an awful time.
Just one more point on that. I'm glad that you mentioned like the different ways you can be a paleontologist, right? Because often we have this image of who a paleontologist is, and really the field has so many different specialties and disciplines and everything else. So even amongst just that umbrella of paleontologist, you have people who you might be a college professor, you might be a curator at a museum, or a collections manager, or a preparator, or mitigation is a big one, especially in states like California. There are plenty of people, if they're going to build like a new building or a highway or something, you go out and you see if there are fossils and you basically rescue those. And like my career, like I'm still very much involved in paleontology, even though I'm not necessarily a professional paleontologist, and that's not my paycheck. I'm not staffed somewhere, but I got into it through writing and through media. So there are all these different sorts of pathways that, just if somebody tells you like, well, you can't, Indiana Jones it, or we don't have an opening for a professor here, there's so many other ways and different pathways and ways to get involved in the field. And if possible, it's kind of expensive. It's not always easy to do. If you can go to the Society of Vertebrate Paleontology meeting, which is our annual meeting. That's kind of the big meeting for everybody who studies everything from fish to birds to mammals, whatever vertebrate group it is. That's a great place to meet folks, see what kind of research is being done, where these institutions are, and that can be a huge one.
And then if you're into invertebrates or plants, then GSA would be the one for the US. And then there's also regional ones like the Western Association of Vertebrate Paleontology. Yeah, and then when you're thinking about like what you end up wanting to do as a job, there's also the question of what's my terminal degree gonna be. So like if you want to be a preparator, there's probably no reason for you to go all like 4 to 6 years to get a PhD. You're probably good with just a master's.
For sure.
Thank you. There's another question here from James. He says, when did the earliest documented study of dinosaurs occur?
Earliest documented study of dinosaurs. Okay, so one of the cool things about this is we've known, basically people have known about dinosaurs before we had words for them, particularly indigenous cultures in North America and around the world. We're finding fossilized bones of dinosaurs and other organisms and coming up with ideas about what they were and how they related to the world. And often like their understanding was more of like these were animals or once living things, versus a lot of sort of scholarship that was coming out of like Western Europe during like the Middle Ages and things like that, where it's like, well, fossils, nothing could be that old. So it's kind of interesting that in some ways, what we might call pre-scientific knowledge of fossils was starting to get a little bit more right than the earliest scientific descriptions that we have of fossils that were coming up in like the 1600s and 1700s. In terms of dinosaurs themselves specifically, they didn't really show up in the scientific record until the early 19th century. And it was 1842 that the word dinosaur was first coined. It was based upon 3 different fossil reptiles that were found in England. And that really began the scientific trail for dinosaurs. So we've been like finding them and thinking about them for far longer than we've even really had a word for them. And I feel like so much of early science about dinosaurs was very much based in Western Europe and in the United States, and it's lately been expanding to so much in so many different places all over the world. We're having all these big conversations about colonialism in paleontology and how that changes things. So, some of this stuff, it makes me wonder sometimes if the science of paleontology, if our scientific understanding of dinosaurs had started in another place, in a different part of the world, what would we think about these animals? What would we call them? So even though we have this kind of agreed upon language, it's important to know the history of these things, like who's coming up with it and who kind of had the privilege and the ability to study them and come up with the terminology. So even though the formal record goes back to the early 19th century, there's a much longer, more expansive informal record.
Yeah, I remember there was a video I had that was it was an episode of a show, I think the Discovery Channel put it out, and they were talking about early dinosaur work. And there was this Chinese folktale that they read an excerpt of that was talking about, I forget why, but a dragon went up on a mountain and died, and there was his bones. But they were describing some big extinct animal, or not, yeah, dragon. They were describing some kind of big extinct animal that they found bones on the mountainside, and they thought it was a dragon. But it could have been a dinosaur, or it could have been an ichthyosaur, or something like that.
I love the Chinese folktale, and I also love the colonialism and paleontology. That's super fascinating. I'm afraid we're almost out of time, but there is still one question, a short one from the audience. And they said, what was the vertebrate paleontology event in the US that you mentioned? He wants to write it down.
Society for Vertebrate Paleontology. This year it's in Toronto, and it starts on Halloween. But it's in a different place every year, and every few years it's going to be outside the US.
Yeah, and it's a great one to go to if you want to see like the latest research that's being done and all different, and all the different forms of research that's being done. It's a great thing to plug into.
Well, Riley, Jess, thank you so much. This has been absolutely fascinating, and I cannot wait to read the book. Thank you both so much. You can order The Last Days of the Dinosaurs at northshire.com, and we'll see you at another Northshire event soon. Thank you, guys.
Thank you so much. It's been great.
Take care. Have a great evening, everyone.